Okay, so as we saw in the last video, in order for an individual statement to make sense, in order for a statement to be able to communicate something meaningful, it has to adhere to the rules that apply to statements. It has to adhere to the rules of syntax and grammar and semantics and so forth. And if it violates those rules, it may lose some of its meaningfulness. So I might make a statement like this to you. I closed all the windows. Now that seems like a sentence that makes sense, but it doesn't make complete sense because you don't know whether I'm talking about the windows on my computer screen or the windows on the side of my house. That sentence violates a semantic rule. It's ambiguous. It has at least two interpretations. So it's not as meaningful as the sentence like this. I closed all the windows on my computer. Okay? So when I start to violate the rules, what I'm saying starts to lose some of its meaningfulness. If I significantly violate the rules, like this first sentence here does, it significantly violates the rules of syntax, then the sentence itself becomes nonsense. It doesn't carry any meaning beyond the meaning of the individual words in isolation from one another. But of course, we don't do most of our thinking about our lives and about our world with individual isolated statements. We do our thinking about the world in groups of statements, right? We offer explanations of things. We describe things with sets of statements. We make arguments about what the right thing to do is or what's true using groups of statements. And just like there are rules that govern the meaningfulness of individual statements, there are also rules that govern sets of statements. And that's what we're going to be looking at in our class. We're going to be engaged in the study of the rules of thinking by looking at series or sets of statements that reflect a pattern of thought or a thinking process. And our question always is, can I rely on this thinking, the thinking that I'm doing, or the thinking that's being presented to be by another person? Is their thinking reliable? And to answer that question, we're going to have to apply the rules of thinking to the thoughts that are being offered to us, to the arguments that are being offered to us, to the explanations that are being offered to us. And if those thinking processes don't adhere to the rules of thinking, then the thinking is going to become less reliable. Now, of course, what the rules are that we would use to evaluate thinking is going to differ depending on the type of logic that's required or the type of logic that's being used. And there are different types of logic, and you know a lot of them already. In fact, one of them you use every single day, multiple times. It's called inductive logic. This is the kind of logic that you might use in your biolab or your chem lab. You do an experiment on some bacteria. You put a substance on the bacteria and you watch to see what happens, and you do it again and you start to notice a pattern. You think to yourself, boy, every time I put this substance on this bacteria, the bacteria dies. And so then you would draw a conclusion. You draw a conclusion that reflects new knowledge about the world and the way that it is. You might draw the conclusion that this substance is toxic to that particular bacteria. But you know your chem instructor is going to apply the rules of inductive logic to your thinking that led you to that conclusion. So your instructor might say something like, was the bacteria that you used representative of that kind of bacteria? Was it typical or was it atypical? Because if it's atypical, we're not going to rely on your conclusion as much. But if it was representative, if it was a typical form of that bacteria, then good, you've satisfied that rule for inductive reasoning. And then your instructor is going to ask, and how many times did you actually do this experiment? Once? You drew this conclusion based on one experiment? You violated the rule of sufficiency, right? So if you're having memories of your stats class and thinking about all of the rules that apply to inductive reasoning and knowing that when we violate those rules, then the conclusion becomes unreliable. The thinking becomes unreliable. And we use this type of logic to address all kinds of questions. So somebody asks us, does Denny's serve good food? And we have a particular answer to that. We say, absolutely, Denny's serves fantastic food. But of course, the person's going to ask us questions about how we came to that conclusion. How many Denny's did you visit? And how many things off the menu did you sample? And did you go to only one Denny's? Did you go to different Denny's on different days of the week and sample different things off the menu? Okay, and those are the rules that govern the thinking that we might use to respond to a question like this, or a question like this one, is John a mean person? At this point, I don't think you can satisfy the rule of sufficiency or representativeness to draw a conclusion about me and whether or not I'm a mean person. You've had, what, 10 minutes of experience with me so far? So you couldn't adhere to the rules of inductive logic and develop an answer to this question that would be reliable. Will lowering the speed limit on Highway 255 lower annual fatalities? Again, we might look at statistics. We might look at examples of other areas that have lowered speed limits, and then we might come to a conclusion. And that conclusion is going to be tested by an evaluation of the thinking process that we used to get to that conclusion. So you use inductive logic all the time. Now, sadly, we're not going to be looking at inductive logic in our class. Instead, we're going to be looking at deductive logic, which is super cool. And I'm going to show you an example of deductive logic right now. All right, so here's a scenario I want you to think about. You got this friend, Jerry. And Jerry has a dad who is an unfailing truth teller. Jerry's dad has never and cannot. He's just physiologically incapable of telling a lie or breaking a promise. And Jerry's dad has said to Jerry, Jerry, if you eat a maggot sandwich, I'm going to give you permission to use the family car. Okay? So Jerry's dad has made a statement to Jerry that is true. If Jerry eats a maggot sandwich, Jerry will get to use the family car. And then there you are standing right in front of Jerry and his dad as Jerry takes a bite out of that maggot sandwich. So then the question for you is this. Will Jerry get to use the family car? Really? So his dad makes him this promise. His dad cannot break the promise. He's just incapable of doing it. If you eat the maggot sandwich, you will get to use the family car. And Jerry's dad witnessed him eating the maggot sandwich. Is Jerry going to get to use that family car? Is there any way that Jerry's dad could deny him permission, given that he's already told him, if you eat the sandwich, you'll get to use the car, and he did, in fact, eat the sandwich, and Jerry's dad agreed he ate the sandwich. Now consider this scenario. The first rule still applies, or not first rule, first statement still applies here. Jerry's dad, the unfailing promise keeper, truth teller, tells Jerry, if you eat that maggot sandwich, you're going to get to use the family car. And then lo and behold, you see Jerry the next day, and Jerry says, check it out. I got permission to use the family car. Can you draw the conclusion from that Jerry must have eaten the maggot sandwich? Okay, so think about those two scenarios for a second. Okay, we might, in fact, make it easier for us to think about them by actually putting them in a formal argument. Okay, so our first scenario would look like this. If Jerry eats a maggot sandwich, then he'll get to use the family car. Jerry ate a maggot sandwich. Jerry will get permission to use the family car. Okay, so the question I would have for you is, if it turns out that this statement is true and this second statement is true, then can we extend our knowledge about the world and conclude that this third statement would also have to be true? Or I might ask it this way. If it turns out this first statement is true and the second statement is true, is there any way this third statement could be false? Is there any way that Jerry could be denied permission? We might frame our second scenario like this. Jerry eats a maggot sandwich. He's going to get permission to use the family car. He will get permission to use the family car. Does that mean he ate the maggot sandwich? And so the question for us in looking at these two arguments is this. Are they reliable? In other words, if sentences 1 and 2 in each of these arguments is true, would the third statement have to be true? Is there any way the third statement could be false? Now, if you really want to play around with this, you should pause your video and come to a conclusion before I give you the answer. All right, so I've given you time to pause your video. This first argument, first of all, you'll notice that with both these arguments, they can't contain exactly the same words. They're just in a different order, right? So it's just like that individual statement that I gave you. Depending on the ordering of the words, the sentence was either meaningful and reliable or not. Okay? And the same is true here. Depending on the ordering of the words and the arrangement of the statements in relationship to one another, maybe these arguments are reliable or maybe they're not. In this first scenario here, this is a good argument. This is a reliable argument. We would call this a valid argument. There is absolutely no way for statement number 3 to be false when statements number 1 and 2 are true. If in scenario number 1, statements number 1 and 2 are true, that third statement will also have to be true. So we can rely on this argument right here. We can trust it. We know that the statements are arranged in such a way, and we'll learn what's in particular is going on here later on. These statements are arranged in such a way that guarantees that conclusion will follow from this argument. But look over here. Same statements just arranged in a different order. Okay? We've got this second premise being pulled out from this first one right here. Same words on the page, but I can think of a way that it is true that if Jerry ate the maggot sandwich, he would get to use the family car. And it's true that he did get permission to use the family car, but that doesn't necessarily mean that he ate a maggot sandwich. Maybe Jerry's dad said, oh yeah, you know what, and if you mow the lawn, you get permission too, right? So this argument's unreliable. Maybe it's true that Jerry ate that maggot sandwich, but it doesn't have to be. I can think of a way where this conclusion would be false, or could be false, even when these first two statements are true. Okay? So in scenario number one, this thinking is reliable. We can trust it. It follows the rules of thinking. But in scenario number two, no, not good thinking. It violates the rules of thinking. It violates a particular rule called affirming a consequent that we'll talk about later. Okay? But this is what we're going to be looking at in our course, is how are the ideas that people offering us arranged? And can I trust them? Or will I be tricked? Is this person trying to trick me? Okay? So next up, what we'll look at, we'll start getting into some of the meat of the course. And in the next video, we'll look at what you need to get in order to move forward in our class.